All right, so we're here at the University of Waterloo, and we have systems designs engineering, right?
Yes.
We have some students here who have done a beekeeping project, so I'll just get you to introduce yourselves.
I'm Jason Pye.
I'm Paul Vanderbilt.
My name is Afshin Garashi.
Angela Kim.
All right.
We're fourth-year systems design students at the University of Waterloo. So what we're presenting today is a project that we call B.E.E.S, the Beekeeper Effort Enhancement System. It's something that we've developed to help beekeepers to reduce both the difficulty and frequency of beehive inspections. So right now, the keepers, they need data to understand. The better the data they have about their hives, the better the decisions and actions that they can take. So what we want to do is make it easier for them to get that data. Currently, you use the Langstroth hive, usually, which is a stack of boxes that's vertical. The most important data is in the bottom box, but you have to remove all the other boxes to get at that data. So what we've done is we've made an n by m array, so it means you have vertical height as well as horizontal width for arranging your boxes. And that reduces the number of boxes you need to remove to get to the bottom, and it also places them at a height where they're easier to reach. We have a sensor suite that can monitor the hive for you, which...
Let's just look in here. All right.
Yeah, so the first thing is an imaging sensor. We have a camera over here. It points downward at the varroa tray. We also have a lighting system. It all points down to minimize disruption to bees, any visual obstacles that are there when we're imaging. So this imaging system can basically replace what people already do, which is counting the number of varroa on the tray, every day, maybe for 3 consecutive days. We are automating that counting procedure, and we're trying to make it so that the beekeeper doesn't have to go physically to the hive to see how many varroa they have. So after we take a picture, we send it wirelessly, and then we have an image processing algorithm which identifies how many mice there are. It filters out all of the other garbage that falls down.
You want to show a picture of that over?
Sure.
All right.
So this is the image that we think is representative of what you see at the bottom board. So the little brown spots being varroa, and you have wax and pollen and other things. We have a color filter which takes it from this image to this image. Oops. And then the white pixels you see here are what we've identified as varroa. So then getting a population estimate is just a matter of counting the white pixels.
Okay. Great.
And Jason, do you want to touch it?
Right, so we also have weight sensors on the bottom of this box, which the cross-section looks like this. So there's a sensor that goes in there, and when you place the hive down, it pushes against the sensor. And that'll transmit to our microprocessor, which then transmits it and posts it to the website.
Okay, and what do you use the weight data for? Just
Well, you can track trends in honey production or the weight of the bee population. Just weigh the hive.
Also good for if the hive gets tipped over, you can be notified immediately so that you can make it to your hive before all of your bees decide to fly off.
Right.
Also during the winter, if you're not sure when you have to start introducing the feed, you can monitor that, and then once the weight gets low enough, you know that they're running out of food and know when to go and give them the feed so they can get through the rest of the winter.
Okay. I'm really curious about the side-to-side hive layout here that you have, and if you guys could talk a little bit about that.
Yeah, okay. So, obviously we're doing that so you don't have to go as high, right? Okay. We've extruded it out like this so that you can use the typical Langstroth lid, which has this overhang. Without this, it wouldn't be possible. You have to use a different lid.
Okay.
So, it's like that. And so we also have these handles on this bottom box here, which are the same, stick out the same as this one. Which means that if you stick this box and that box, so the handles are together, you know that whatever you put on top is going to align perfectly.
Okay.
Also here, when the holes aren't used as passageways, you can cover the holes with a plexiglass window.
Okay.
And then add this shutter, which is affixed with a hinge and 2 screws. And so this allows the bees to regulate their own environment. And there are magnets that pull this down against the weatherproof stripping, again for that same purpose. And also it blocks out the light. And so the bees, obviously, when they see the light, they feel that there's a hole in their hive, and they cover up the window. Okay. So you wouldn't be able to use it as a viewing port. So now the bees won't do that because it's covered up properly.
Okay. Great.
That make sense?
Yeah.
have any other questions?
I think that's it for now. It looks like you guys have done a great job, so we'll leave it at that. And just wanted to thank you guys all, and congratulations on your project, and all the best. All right, cheers.